Welcome everyone to another video of fluid mechanics where we are going to discuss buoyancy and equilibrium of submerged bodies. So what is buoyancy? Buoyancy has been defined by Archimedes as a force acting vertically upon a submerged body. The force of buoyancy or buoyant force will be equal to the volume of liquid displaced by the submerged body. You should notice that the buoyant force always acts vertically upwards, and that force will be acting through a center of buoyancy. The center of buoyancy is not always center of gravity of the body. Center of gravity is where the mass is concentrated, whereas center of buoyancy is where the volume is concentrated. So that is basically the centroid of the displaced volume, and the force of buoyancy always act vertically up. So let's consider cases of equilibrium of submerged bodies. The submerged bodies achieve equilibrium depending on where the center of buoyancy and center of gravity is within the body. There are a few cases we need to consider. Let's start with a case where a body is completely submerged in the water or in a liquid, and the center of gravity is below the center of buoyancy. So a weight of the body will be acting through center of gravity downwards, and force of buoyancy will be acting through center of buoyancy upwards. So that's what I've shown here: weight downwards, force of buoyancy upwards. Now let's say the body is tilting clockwise. So if the body tilts clockwise, the weight and the force will still act vertically upward and downward. However, there will be a distance between them which will create a couple, and in this arrangement the couple will be counterclockwise and forcing the body to come back to its original position. Now if the same body, if it tilts counterclockwise, the moment created as described here will be clockwise, forcing the body to go back to its original position. So that's called a stable equilibrium condition of a submerged body. Now let's consider another case where the center of gravity and the center of buoyancy are changed in their positions. So in this case, the center of buoyancy is below the center of gravity. So center of buoyancy is below and center of gravity is above. So the force of buoyancy is acting vertically upward, and the weight of the body is acting vertically downward. Now if the body tilts clockwise, as you can see in this figure, the moment created as a result of this tilt will continue to force the body to tilt in the same direction. So as you can see, there is a distance created between the line of action of these forces, the force of buoyancy and the weight, and that couple or that moment will force the body to tilt or continue to tilt in the clockwise direction. The same will result if the body tilt counterclockwise direction. The moment generated in this case will be counterclockwise, forcing the body to continue to tilt in the same direction. So as you can see, the moments are not forcing the body to go back to its original position, and therefore this equilibrium is called an unstable equilibrium. The center of buoyancy is below the center of gravity. Now let's consider another case. We have considered force of buoyancy is either below or above the center of gravity, and in this third case the force of buoyancy is right on the same place as the center of gravity. So force of buoyancy and the center of gravity, or buoyant force and force due to the weight, both acting at the same point, one acting upward, one acting downward. So as you can imagine, if the body tilt to the clockwise position, the forces will still be acting at the center of gravity and the same point, and therefore they will cancel each other. And because there are no distance between the two forces or line of action of the two forces, there will be no moment created regardless of which direction the body tilt, whether it's clockwise or counterclockwise. The forces will cancel each other and no moment will be created, and therefore this equilibrium is called a neutral equilibrium, where force of buoyancy and center of gravity acts at the same point. So we have considered three cases where the force of buoyancy in the first case was below the center of gravity, and in the second case was above the center of gravity, and in the third case was right on the center of gravity, and we have named them accordingly. The first case was a stable equilibrium, and the second was an unstable equilibrium, and the third was a neutral equilibrium. So I'm repeating the cases here. As you can see, the weight below, or the gravitational force below the force of buoyancy, that will be an unstable equilibrium, and force of buoyancy and center of gravity acting at the same point, that will be a neutral equilibrium, and force of buoyancy acting below the center of gravity, that will be unstable equilibrium. You should notice that for a complete submerged body, the force of buoyancy will be equal to the weight. So Fb is equal to the weight of the body. So the first figure is the stable equilibrium, and the second figure is the neutral equilibrium, and the third one is the unstable equilibrium. So these are the three cases of a completely submerged body. If the body is partially submerged, then that is a totally different case, which we will discuss in a later video. So stable, neutral, and unstable equilibrium. These are the three cases we need to consider for a completely submerged body. Once again, thank you for watching. Please comment if you need any more details on this video or other topic, and I will get back to you. Thank you very much.